Hi everyone, we will be getting started in just a minute to let some stragglers log in and whatnot, so hang tight. Hello everyone, thanks for joining. My name is Cassie Rowe, Content Marketing Specialist at 451 Research. Today's webinar, Unraveling the Confusing World of IoT Economics, will be presented by Owen Rogers, PhD, Research Director of the Digital Economics Unit, and Christian Renaud, Research Director of the Internet of Things. Before we dive into the content, I just want to give a brief introduction to 451 Research for those of you who aren't familiar with us. 451 Research is a top-tier research and advisory firm headquartered in New York City. Our team of more than 100 analysts cover more than 200 technology vendors and service providers every year. 451 Research provides unique insights into emerging disruptive technologies and the companies taking them to market, and deliver that insight via syndicated research, advisory services, and live events around the world. Now, before I turn it over to Owen and Christian, just a few housekeeping items. The webinar slides can be downloaded in the attachments and links section of the BrightTalk platform. You can submit questions to the presenters in the same platform for the Q&A at the end of this webinar. And the webinar recording will be available immediately after today's session. Without further ado, take it away, Christian.
All right, thanks, Cassie. And welcome everybody to the webinar. Good morning, good afternoon, good evening, depending on where you are in the world. Just real quickly to give you a little bit of background on our IoT efforts at 451, and then Owen's going to talk about our cloud economics efforts. We take a very holistic perspective on IoT, the market, ranging from mergers and acquisitions and investment coverage, where the money's flowing is sort of a concurrent or a leading indicator, looking at customer demand side information. So we do multiple surveys across consumer, enterprise, and service provider. And in the context of IoT, that's IT professionals and non-IT professionals, what IT people refer to as OT professionals. So we look at all of those segments for where customers are actually deploying projects, what their priorities, their headcount, their budget, favorite vendors, types of workloads. And you'll see some of that data in just a moment. We also have our Global IoT Market Monitor, which is a baselining tool for market sizing and directionality for people that primarily vendors that are looking to develop new products and services, and where they should focus their energies based on, for example, how large specific sections of manufacturing are in given countries, for example. On top of that, we layer our qualitative insight, our technology and business or insight reports, which are longer form discursive reports, and then shorter, more snackable market insight reports, such as impact reports and analyst notes, spotlights, those sorts of things. And it's the combination of all of those that allows us to take a look at the market qualitatively and quantitatively. Owen.
Thanks, Christian, and delighted to be here. I run the Digital Economics Unit here at 451 Research, and essentially we provide a lens of intelligence into what's going on in terms of economics, pricing, and value differentiators in the cloud and IT markets. And something I architected a few years ago was the Cloud Price Index. And the Cloud Price Index essentially provides a number of benchmark and data services to enable enterprises and service providers to ensure they're always getting best value. And we structure this in a number of ways around the ideas of reacting, developing, and justifying price and value economics. And the first step that we take, the first approach to collecting data, if we scan the websites and the APIs of Azure, Google, and AWS, every week, every product across all regions, around 450 to 500,000 SKUs, and we look for any changes in price. And you'd be amazed how often things change that aren't announced, but have a big impact on enterprise spend and on service provider differentiation. The next data source we collect is from surveying cloud providers for their pricing. We do this on a quarterly basis for public cloud, 50 cloud providers representing 85% of the global infrastructure as a service market across 4 regions of the globe. And once a year as well, we collect data for our private cloud index. And we released this data in a number of PowerPoint deliverables, but a new thing we've launched last year was our analytical tool. So service providers and enterprises can price up their own basket of cloud services and see how the benchmarks and distributions vary depending on the region and depending on the time of year and into the future as well. And with that, I'll pass on back to Christian.
All right, thanks, Owen. So what we're going to do real quick is just sort of frame the IoT market and the IoT cloud and platform market as prologue for Owen's analyses on the economics and really where the key levers and factors are for cloud pricing when it comes to IoT projects. So let's just dive right into that. First and foremost, obviously, it should come as no surprise to anybody on the call that IoT adoption is going strong, it's growing rapidly, and it's actually getting to the point now where it's being absorbed into the background. We're seeing less IoT for IoT's sake conferences and more as part of this manufacturing conference like Hannover Messe in Germany or HIMSS in Las Vegas for healthcare. And it's just being absorbed as a given. It's no longer a discrete, separate event or technology inflection point. It's really a broader global transformation towards connectivity and analytics. How this is manifesting, if you talk to information technology buyers, is a lot more activity around the things that they know, for example, data centers, premises security, smartphones, tracking people around retail establishments, for example. And then usually information technology buyers, eventually, if you ask them, they'll get into, oh yeah, and we do this in our factory or possibly our fleet. If you start with the people who don't have IT in their job title, if you talk to operational technology buyers, they're far more inclined to say, here's what we're doing for condition-based maintenance on the factory floor, or here's what we're doing for fleet management in our vehicle fleet. So it's an ongoing transformation, and it's something that's been going on, quite frankly, since before the industry invented the term Internet of Things. It's just a broader connectivity, broader data extraction, and out of these proprietary silos and formats, and into something that can be analyzed. Having said that, because you're capturing a lot of work in progress out of manufacturing, transportation, energy, healthcare, a lot of the original analytics, a lot of the initial analytics rather, is done on premise, not in the cloud. And that seems to be a surprise to a lot of people with IT backgrounds, because cloud is the answer. Generally, what is the question? But in IoT, the legacy has been more around edge compute and edge analytics because it predates the invention of the cloud. So what we see either the first wave of analytics, that first pass might be a control loop pass, is going to happen on the device or on a sidecar PC hanging off like an operator console, or on vehicle, obviously, for reasons such as you don't want to go to the cloud, apply the brakes to your semi-truck. And then within either on the factory floor, in a caged off area, in a closet, or possibly even in a data center on premise. And that's where the majority of analytics occurs today. Now, what we see then is if you go to the subsequent pass, the subsequent analytics pass, those far more frequently are finding their way to the cloud versus the initial pass where it might be on premise. There are exceptions to that. For example, in electric utilities, the customer-facing side of that begins in the cloud more often than it begins on premise for you being able to pay your water bill or electric bill. But it's important to note that that is growing very rapidly. That's the fastest growing segment is cloud-provided IoT services. It's not to say that, and the reason for that, sorry, let me back up. The reason for that is because there are sectors, for example, smart cities and healthcare that are more early adopters, retail, that are more early adopters of IoT technologies. They don't necessarily have that legacy base that you get in manufacturing and transportation and electric utilities. Those are starting with cloud-based solutions. That's usually what's being offered to them, which is okay because the applications that they're running aren't necessarily the most latency sensitive. They're not looking for a sub 10 millisecond latency, and they can absorb the round trip time to go to the cloud and the benefits with all of the deeper data integration that brings. So it should come as no surprise. We track about 600 IoT platform vendors. And IoT platform is a rather nebulous term that includes everything from people like Cisco and Nokia and Ericsson, who do device connectivity and management platforms with their roots in mobile devices and onboarding mobile phones and tablets and things like that, all the way through to companies like GE with Predix or Uptake or Salesforce, where you're doing more application and analytics and really running business processes. And it's that entire spectrum. Now, having said that, a lot of these platforms or a lot of the applications that people are playing with, at least initially, start with a public cloud provider, so an Amazon, a Google, or a Microsoft, where these other platforms will reside on top of that infrastructure. So you might have, for example, GE Predix running on top of an Amazon or a Microsoft. So if you were to ask a customer, which we do on a quarterly basis, what infrastructure, what platforms are you using, they are most likely going to give you multiple answers because some of those are application platforms and some of those might be infrastructure or platform as a service. So the first three are Microsoft, Amazon, and Google in that order. And Amazon had been in the pole position for quite some time since we started the survey. And we've seen Microsoft gradually rise up and just most recently surpass Amazon as the public cloud provider of choice for IoT services. This is part of the rationale, as Owen will get to in a moment, for the initial study that we did on cloud economics for IoT. So what is driving the purchasing process for early adopters in IoT, or even if they're mid-project, just recently rebranded as IoT? The key drivers, the selection criteria, are going to be, the initial partners for a lot of these customers are those cloud providers. And the reason for that is that allows, for example, IT staffs that may not be familiar with the suite of technologies to get familiarity, to get up and running with a trial relatively quickly. So not surprising, public cloud providers, usually shortly after that, systems integrators come in and they talk about how to integrate your existing information technology infrastructure with whatever parts of the business that you're instrumenting for IoT, if that's the factory floor, if that's the fleet, if that's the grid, if that's the hospital bed. Those leaders come in, and they are a very critical component. I can't emphasize this enough, because information technology vendors, by and large, are used to selling pieces of a solution that the customer then assembles into an outcome. If you look at operational technology and the business, if you would, the non-IT parts of an organization, they're more accustomed to buying solutions and outcomes, writing a check to make the problem go away or to make somebody else make the problem go away. Whereas information technology, I'm going to buy a component from vendor A, a component from vendor B, a component from vendor C, and then I will be responsible for assembling those into my desired outcome. So that's an important distinction, and therefore systems integrators prove key moving forward to pull all of these multiple vendor solutions together into, again, what the outcome that the business desires. And then we're seeing things where a hardware OEM or maybe a software provider, analytics provider are the first person through the door, and they go, great, we can help you with this digital transformation effort. Let me bring in some of these other people that I work with in smart cities or in healthcare, and they'll round out the entire solution like a systems integrator. And the selection criteria for that, there's a couple things. One that's not listed in here is, but turns out to be quite key in the in-depth interviews that we perform when we do these quantitative surveys. This is from our Voice of the Enterprise IoT surveys, is data gravity. So do I have an existing, for example, cloud relationship with Amazon or Microsoft or Google? That's going to influence which solutions I select, because they need to be able to reside on top of my platform of choice or my cloud provider of choice, because of the data gravity that we already have there, and because I know that whatever machine data or human data, whatever the IoT data is going to need to intermingle with that at some point downstream. In summarized, it might be a subset but we know that we're going to cross those streams, and I don't want to get hit with cloud-to-cloud transfer fees. So that is a key consideration. Having said that, the perennial fear for all these IoT projects is I'm opening up a greater attack surface for these machines, for these individuals, for these devices that historically hasn't been exposed, say, to the capital I internet or to a network. It's been theoretically air-gapped behind some proprietary protocols, maybe not connected via IoT gateways. And so there's a lot of concern that these devices are going to become compromised because they don't necessarily have the immune system that we're accustomed to with antivirus and other things that you might get on a typical data center server. So security. The second thing is, does my team actually have the expertise to implement these projects? And it's funny, when you go ask enterprises, they will admit, I'm most concerned that my team doesn't have this expertise. I hope that the service provider, the cloud provider, the platform provider that I have is able to bring some of that expertise in and co-create outcomes for me to achieve my digital transformation goals or whatever the business objectives may be. So that might come from the technology provider, the platform provider. It might come from a systems integrator. Depends on a case-by-case basis. And then most recently, we talk about long-term viability of the platform. And I mentioned at the onset of the conversation that we track about 600 IoT platforms. It'd be fair to say that probably 75, 80% of those are specific to, they have their roots in probably embedded computing, maybe some technology integration in ATMs or vending machines or something like that. And only just recently have those been sort of read and brushed up in new trade show collateral that says they're an IoT platform. So it's great that these companies have this expertise. It's very, very valuable that they have actually done it. They've been in the trenches and actually delivered. But there's obviously a component of risk if I'm a large organization and I'm going to standardize on an IoT platform from a company that may or may not be there in a quarter or two. I'm taking a risk in that regard. So we see the energy drifting towards the larger platform providers for that very reason, because one of the things about standardizing on a platform is making it doesn't become a liability later. And with that, I will turn it over to Owen, now that we've framed it a little bit about the IoT platform market and the cloud market specifically, and Owen can talk about this specific study.
Thank you very much. One of the great things about working for 451 is we're encouraged to follow our noses. So if we see something interesting going on in the market, we're free to go and investigate it and write about it and work out what's going on, because it's these types of insights that have the most value. And we detected using the Cloud Price Index about 3 months ago that Microsoft made substantial cuts to their IoT platform, around 50%. So that got Christian and I thinking, was there a way we could somehow determine which of these 3 aforementioned cloud providers was the cheapest for IoT? And we discussed a bit, and after quite a long process of considerable pain, we came up with a number of surveys, results, and hopefully I'm going to present some of that data today and show you through what we found. And we decided to stick to the core IoT functionality, which we're going to refer to here as cloud IoT platforms. And as Christian showed in his Voice of the Enterprise data, that includes AWS Core, Google Core, and Azure Hub. And these are recognized as being the 3 major cloud IoT platforms. And essentially, these services, A, provide a broker interface for sending and receiving messages. They, B, maintain a database of device states. In addition, they provide and maintain a database of devices, and some as well also trigger events in response to rules. So all of these IoT platform essentially deals with the aggregation and distribution of IoT messages, states, and devices. And all 3 of these are, the core functionality of their billing all comes down at the very root of it to the total amount of data transferred. Now, Google has the simplest model because they charge literally in terms of the data. If you transfer 10 gigabytes of data between your devices and the core platform, then you pay for 10 gigabytes of data. Microsoft do it somewhat differently in that they charge for messages, but messages are essentially an extension of data. And Microsoft require you to buy certain bundles of message capability and consume that over the next month. And AWS has the most complicated model. AWS essentially charges based on messages, but also in terms of connectivity. So how long are those devices connected to the core platform? So on the face of it, the pricing models all look fairly simple. But then you start to get down into the nuances. And the nuances are tucked away on the pricing pages in the tools. And some of these nuances have a real impact on total cost of ownership of these IoT platforms. The first one of these is how big is a message? Now, each of these cloud providers have their own definition of what is a message. And a message is defined as a certain size. Now, if you were to send a very large message, these cloud providers would bill that as a number of messages depending on what their maximum message size is. So even though it appears you're just sending one message, when it comes down to billing, you might be sending numerous. And each of those messages has a cost implication. Each provider also has a different definition of what constitutes a message. So some providers will let you ping for free, for example. Now, in an IoT implementation, you might want a device to ping the platform such that connectivity remains. Some providers will let you do this for free. Others will charge you for doing so, and this can have an impact on pricing. The issue of capacity planning is also a factor. Google and AWS bill in arrears. You consume however much you need, and at the end of the month, you're essentially given a bill for how much you consumed. But with Microsoft's model, you have to buy that capacity in advance. You have to mix and match their message bundles to ensure you have the right amount of capacity in advance. If you buy too much capacity, you've essentially bought capacity which is wasted. If you buy too little, you might not have enough to perform for your requirements. So the capacity plan issue is not one we were expecting to find, but it does have an impact. Another issue is administration. So obviously you're going to send some messages as part of your administration capabilities. You're going to need to add devices, remove devices, update the message state. And each of these providers do those messages for administration in different ways. And then finally, how about rules? Are rules to divert messages, to trigger events, are these included in the services or are they different? And what initially we thought would be a fairly simple exercise, we discovered that there were 9 pricing parameters that would impact which of the cloud IoT platforms were cheapest. And each configuration of these parameters would impact cost in different ways. So to find out who is the cheapest provider means that we'd essentially have to try and analyze every possible configuration of these 9 pricing metrics, of these 9 parameters. And prior to the cloud, prior to computing, it would have been impossible. But fortunately, we just decided to do a brute force approach. And the only way we could work out how to do it was to test every configuration, or rather a large sample of these configurations. And this is how we did it. We built Python simulations of AWS, Azure, and Google's pricing. And each of those Python models allowed us to input a parameter, input a set of parameters, and it would output the total cost. We built them in Python based on the pricing models from the service providers' websites. We compared the outputs to that we got from the tools and outputs as suggested in the examples on their websites. And we also run our outputs and our use cases against the cloud providers themselves to check they were accurate. We ran those Python scripts 10 million times. And each of those times we inputted a different random configuration of the price parameters we had identified as having an impact on cost. This resulted in 10 million lines of effectively training data. We uploaded that training data to an analytics platform, and we asked the platform to tell us what input parameters impacted the output cost. And this is what we discovered. So out of those 9 parameters, it's no surprise that the biggest cost drivers turned out to be the number of devices, the size of messages, and the number of messages. So all of these nuances do have an impact, but it is these 3 things that will mostly dictate which of the cloud providers is the cheapest. And then we decided to start to break down into it to see if there were certain thresholds where one provider would be cheaper than another. So essentially, when the number of devices we were simulating was above 20,000, Azure was far more likely to be the cheapest. In fact, when the number of devices were above 20,000, Azure was always the cheapest cloud provider. But when the number of devices was between 0 and 20,000, it wasn't as black and white. AWS would be cheapest in 25% of those scenarios, whereas Azure would be cheapest in 75%. And then we could start to dig down more into this data. And we found that when the number of devices is between 0 and 20,000, and the message size is between 0 and 6,000 bytes, AWS and Azure were roughly 50-50. They were equally likely to be the cheapest. And then finally, we looked at how many messages each device was sending per day. And if the number of devices was between 0 and 20,000, plus the message size was between 0 and 6,000 bytes, and the messages per day were between 0 and 7,000, then AWS was likely to be cheapest in the majority of circumstances. Now, this led us to the conclusion that Azure was cheapest at scale. So for most of the simulations we ran, Microsoft IoT platform was the cheapest. But in this particular circumstance, AWS was found to be the cheapest. Now, our hunch is most enterprise deployments today are going to be in AWS's sweet spot, because most implementations are under 20,000 devices. Most messages being sent are under 6 kilobytes, and very few devices are sending more than 7,000 messages a day. So AWS at the moment is probably in the sweet spot for enterprises. But over time, Azure are in a good place to capitalize as the number of devices grow, message size grows, and messages per day grow. Because then at this level of scalability, Azure is likely to be the cheapest. Now, you might be wondering why Google doesn't appear in these bar charts. And that's because in all of our simulations, Google wasn't found to be the cheapest provider in any scenario tested. Now, in lots of those simulations, Google was found to be the second cheapest, but we never found them to be exclusively the cheapest provider across all the 10 million simulations we ran. So there's obviously a lot more data in the report and a lot more analysts. What I've shown you here is really just one side of a decision tree. And in the full report, we've got a huge decision tree which breaks down which provider is cheapest in which circumstance. But our overall conclusion is, first of all, one that now I have personal experience in that cloud pricing is now so complex, machine learning tools must be used to find best value. Even when we do our weekly cloud tracker, we have to scan 500,000 SKUs to work out what's changing in the market. So for an enterprise to manually, on an ongoing basis, to identify which platform is best value for money, I would say is an impossible task manually. And we've reached the state of complexity now where machine learning and automation is the only way forward. Azure was the cheapest in the majority of scenarios we simulated, particularly at scale. However, AWS has a sweet spot today where it is cheapest. And this is probably where most enterprise use cases are today. But of course, over time, scale will increase and also the pricing models will change too. Google was never the cheapest provider in all of the simulations we ran, but then again, they did come in second position. So all we're looking at in this study is the cheapest. Enterprises should be aware of the nuances when comparing pricing. Obviously, cost isn't everything, but in this market, no one can afford to ignore it, because as you grow, as your IoT implementation scales, your costs are going to go up, and cost is going to be more severely impacting to your budget. And then finally, service providers should consider how they will support IT. Now, one solution might be to act as a broker of IoT services. We hear lots about brokers of cloud platforms, but how many companies, service providers out there are really brokering IoT and finding best value between IoT providers? And I'm going to pass you back to Cassie to arrange some questions and talk about the Hosting and Cloud Transformation Summit, where this handsome devil will be speaking, as well as many other good presenters, including Christian. Over to you, Cassie.
Thanks, Owen. And unintentionally, the lovely gentleman on this slide is, in fact, Owen, just so the audience can have that nice little fun tidbit. Yes, so the Hosting and Cloud Transformation Summit, or HCTS, is our annual event out in Las Vegas. This year it'll be September 24th through 26th. For participating in this webinar, you can receive a $200 discount off of your registration fee by using code IoT200, as you see on the slide. We hope to see you there. And
all right,
thank
Cassie,
you,
should we jump into questions?
Yeah, I was just going to thank you guys for presenting and jump into the first question.
All right.
You're getting ahead of me, guys.
Good. Sorry about that.
I appreciate it. It's awesome.
We're so excitable.
So the first question I have here is, if number of devices raise the cost, is it possible to consolidate data before sending it to the cloud and optimize the messages size and transmission frequency?
So the answer to that is yes, and the reason for that is obviously a lot of IoT data is streaming time series data, and it might be, let's say there's a refrigerator and I'm taking every second or every minute temperature readings off of it because it's a high value asset. Maybe it's holding transplant organs in a hospital or something like that, or cold chain in transportation. It's possible to, before you send that data onto the cloud, say, out of 95% or 99% of the readings that we took, the temperature stayed within acceptable thresholds, except for these 5 data points. And that's a summarization function that's relatively well known. It does require it does require capability at the edge to summarize that data and just send a subset. So it's not something that you can necessarily depend on a point of sale terminal in retail or a street light in a smart city to do itself. It might, you're going to require some device there locally that has that policy baked into it. And yes, that will then lower your overall, the data that you do upload to the cloud so you don't spam the cloud.
So it's a fascinating question, because it just popped in my head that potentially then there's the opportunity to game the system. So you can almost, you could take potentially the findings of the report and gamify the system so that you are paying less, so your particular provider is more likely to be cheaper. Or is there even some kind of break-even threshold where you can take the edge analysis and compare it to the cloud analysis and work out the best balance of compression and balance of consolidation before sending to the cloud, which is something we should look into. It's a really intriguing question about if it's possible to use our data and take it a step further to see how much can you save by doing these things on the edge. So Christian, I will talk to you about that another time.
Think we have a follow-on project suddenly.
Yeah, I think I need a break from IoT for a while.
Well, at least not until after the Q&A done, right?
No. After the Q&A, I'll check out from IoT. I'll leave it to Christian, the expert.
For the most important IoT platform vendor attributes, do you have a vendor ranking for each attribute area?
So we do. In our Voice of the Enterprise IoT, one of the quarterly themes is vendor evaluations. And we break down by industry vertical, by size of organization, and it then yields who are the most prevalent, who are the most dominant IoT platform vendors. Based on that, then we're able to do things like say, how does this vendor perform as far as strategic vision, innovation, product portfolio breadth, value for money, technical support expertise, understanding of your business. So we capture that data around the vendors that they select to anticipate a follow-on question, which is, do we compare vendors based on that? It's very difficult to find IoT customers that are deploying these technologies that have more than one of these vendors at a time. So it's difficult to do a side-by-side comparison of the two because you'll have an Amazon customer rating Amazon, you'll have a Microsoft customer rating Microsoft. They might be using them in two completely different contexts, so it would be an apples and oranges comparison. The only way to do that really viably is if you had a customer that was using both of them in a common context. That's very, very seldom that happens.
All right. Next question is, what I got out of this webinar is that it might make more sense to study pricing models before building products and making decisions based on how they work and handle data. Is that a sound observation?
It's a really tough one because cloud, for me, cloud is exciting because you can experiment and you can take risks. And a lot of things such as IoT are people playing around and seeing what they can do, and then it's spiraling and people doing cool things. And in those scenarios, it's almost like being too focused on the little things can impact some of that creativity. But obviously what starts with a little thing turns into a really, really big thing when you're using it into an enterprise production environment. So I think let people experiment. Don't worry about the little costs when you're getting started. But when you decided to move to production, when you've decided what technology you want to use, then to start looking at the pricing models and then to start to do a what-if analysis. And for me, it's not, you shouldn't always pay the cheapest. I think you should just pay for the value you're getting. And it's at that point after the experimentation, it's time to investigate the value and to investigate how costs can spiral out of control. If you forecast how things are going to change over time and your cloud provider is the best choice, that's fantastic. But what happens if those forecasts don't come true? What happens if you scale up? What happens if you don't scale enough? Make a plan for those eventualities. Make a plan for how you will change. Make a plan for what to do in those scenarios. And I suppose prepare for the uncertain and prepare for understanding your choices. Don't just look at the pricing models with a view to get the cheapest.
Good advice.
Yeah, that's really good advice. Next question I have here is, you show the 3 top cloud IoT platforms based off of number of customers. Do you have the ability to show the top 3 by revenue or customer size?
So the 3, I think the slide that you're referencing is who are the 3 most frequently cited among survey respondents of Voice of the Enterprise, of who they're using, who their platform provider is of choice. So I think it would be a stretch to say that based on number of customers. It's based on those survey respondents, which is obviously a subset of all. The challenge is the 3 that Owen mentioned, those companies do not break out and advertise, we've got this many customers, we've got this much revenue for our IoT service specifically. They might say we've surpassed 100 million connected devices, something like that, but they very seldom will say across 5 customers or 10 customers or 1,000 customers. Primarily because it's still the early stages of the market, as Owen said, with a lot of experimentation, a lot of stuff in the labs where the IT teams are addressing that skills deficiency where they may not know, or they're getting familiar with messaging protocols and things like that. Therefore, what those platform providers probably don't want to say is there's this many people that are in production at scale. whereas there's this much larger number of people that are just kicking the tires and gaining familiarity with it. I think it'll be a while before we get to a common denominator where everybody's comfortable saying that, and I'm looking forward to that day. I just think the market's still a little bit too young for that.
That makes sense. So this next question involves an interesting analogy. So with Microsoft, if your capacity runs out on day 28 of the month, do your products just stop working, like when I run out of mobile data with T-Mobile? Or do you automatically get charged a premium for additional resources, like when I run out of data on Verizon Wireless?
My understanding is your capability gets throttled. So from what I understand, there's no automatic purchasing of more capacity or more bundling. Your throughput will be throttled until you buy a new package. Now, I'm not sure if you can set up an alert. I imagine account manager would let you know that's happened. But from what I understand, it is your responsibility to make sure the capacity is there.
Makes sense. Moving right along, have you found any correlation to cost containment to the use of a third party to deliver managed services of the instances you studied?
Interesting question. So go ahead, Owen.
Well, so I was going to say not many, I don't know if this is your experience, Christian, but I don't see many managed service providers doing management of IoT on third-party cloud platforms. At the moment, it seems to be very virtual machine infrastructure focused rather than focusing on IoT platforms. I don't know many companies like managing IoT on AWS as a partner. Do you? Is that a big thing?
No, it's just, I would say systems integrators that might use that as a component. They might, again, you're creating a gourmet meal. That's one of the ingredients of the meal. Is there any necessary economic benefit to that SI front-ending it or a managed service provider front-ending it? I have not seen one yet, no.
But I'm sure it would be a good opportunity, right? Because as you can see, there's such price differences. Someone should grab the bull by the horns and be this managed service value adder and brokers between these platforms. But obviously, that's a lot more complex in practice.
Right.
All right. Next question. Do they charge, and I'm assuming they is the cloud service providers, charge to generate reports and analytics on data collection from devices?
So generally, yes, because the reports, so when you use the IoT platform, that data has to be sent somewhere to object storage or a database. So you would get additional charges for storing that data, and then some would charge you for executing queries on that data. So yes, there would be additional charges for the use of other services to examine that data.
All right. Next question. Do they charge to generate reports and analytics on data collection from their device? Did I just ask that?
I think you did,
yeah.
There's a really important question here, Cassie. Is being devilishly handsome a hard and fast requirement for a search in the IoT market? I can tell you, if you've met Christian Renaud, that is definitely not the case. So
I was going to say, I'm walking and talking proof that that's not the case.
I have to jump in there, Cassie, before Christian got in there first.
Okay, that's fair. That's fair. But yeah, so that is the deep secrets of the IoT space.
Yeah, right. Moving right along.
The next question is, do you see any scenarios where 100% CapEx on-prem IoT platform solution is more cost-effective than a cloud-based IoT solution?
So, Owen, I'm pretty sure you didn't include that as part of your economic analysis, so maybe I can jump on that one. Usually, okay, so edge versus cloud, or edge is a continuum to the cloud, edge, near edge, and so forth, is an ongoing area of research for the IoT team at 451. And usually it breaks down to about 7 determining factors of if you're going to do the compute, the analytics pass at the edge versus in the cloud, only one of those is, well, there's availability of bandwidth and there's cost of bandwidth. If I'm in an offshore oil rig or I'm in an open pit mine in Western Australia, I may not be able to get the bandwidth that I need in order to do what I need to do. Or if I can, it might be so cost prohibitive, it might be satellite, might be very bad latency that it impairs my applications. So in those cases, we see people going to edge because it's just not economical to, again, spam the cloud with a bunch of low-value time series data if your cost of bandwidth or your availability of bandwidth, for example, on a train or on a plane, isn't necessarily there. So it's that more so than the cost of doing it in the cloud is prohibitively expensive versus the cost of doing it on premise. Usually it's going to be other drivers. It's going to be bandwidth availability. It's going to be data sovereignty, privacy, security, the latency requirements of the application if it's sub 10 milliseconds, sometimes 50 or 100 milliseconds, depending on how far away you are from your cloud provider and the bandwidth. So it's a number of other factors, not just cost in that context. Now, having said that, I mentioned the primary determining factors for selecting IoT platforms, security, expertise, those sorts of things. I was going to provide the slide for this webinar, but chose not to. What we've been seeing rise up in priority is what is the cost of the solution. And what that tells me is now you've got a more educated set of buyers that are looking at return on investment, total cost of ownership, life cycle of these solutions, and cost is becoming a more important factor because they have to say, I'm going to do condition-based maintenance or predictive maintenance on the factory, and it's going to recoup the investment over this period of time. So dollars does end up playing a factor, although still for a lot of the trials, it's can we actually build the applications? Can we turn the traffic and the analytics around fast enough for our specific environment?
All right, cool. So the last question I have in questions from the audience, and just so the audience knows, we have like about 10 minutes left where we can keep answering questions. So if there's something you're dying to know, please pop it in to our little questions portal on BrightTalk. But this question is, what was the spread between the cheapest and the most expensive? How critical is the purchase decision? There's like a bunch of other questions involved in this one post. What is the cost of picking the wrong provider? For example, my data gravity is with AWS. What penalty would I pay if I went with them instead of Azure?
I love a question full of statistics I can give. So the spread between the cheapest and the most expensive on average was roughly 4 times. So the most expensive cloud provider on average was 4 times the cost of the cheapest. So we're not talking nickels and dimes here. That is huge. In some cases, the most expensive was 10 times the cheapest. So it is pretty bad. So obviously, the purchase decision does have a huge bearing. Now, the issue of, so there is a broader issue in that, okay, you choose one cloud provider for your IoT platform, but how about all the other services you use? Well, that is a far bigger calculation, and I've even been thinking of doing some kind of machine learning algorithm to assess all of the products across all of the portfolios, which I might get down to eventually. But what we found is some of the things that are forgotten about is bandwidth. And in the question asked, there's a reference towards data gravity. And that is the problem of, essentially, once you've got data on a cloud platform, it's more likely to attract more data. And what some indicative research that we've done has suggested is that there's a tax of getting the data back out of the cloud. And the tax is roughly 15% of the cost of keeping it in the cloud. So if you pay $100 per month for keeping data in the cloud, you will have to pay $15 to extract that data when you want to take it all back. Now, for $100, that $15 isn't much. But if you're spending millions, then there is a huge amount of stickability there because you're going to have to pay that tax to get it back. So that's why I'm really huge on these what-if analyses. Understand what the implications are of needing to get data out, of what happens if your forecasts don't come true, and then work out how things will change if your strategy changes.
All right. Well, that's all the questions we had in the questions from the audience section. We do have about 10 minutes left, so we can either talk briefly about any ideas that you got, guys, while receiving these questions, or we can wrap it up.
Oh, Cassie, it's nice of you to move back to the slide with my face on it. That's very, very nice of you. Sorry, Christian.
No problem. I didn't have anything additional. Owen, did you, that you wanted to chat about today?
No, I think this was, I really enjoyed this, Christian, so we should do more work together. Thanks, Cassie, for setting this all up. And obviously, any further questions, any feedback, we're welcome to take note of it. Anything from you, Cassie?
That's mostly it for me. Everyone, thank you for joining us for this webinar. Don't forget to save $200 on your HCTS registration with the code IoT200. Also, you can leave feedback in the Bright Talk platform. Let us know how we're doing, if this information was of value, what we can do in the future, all that great stuff. We hope you enjoyed this content and some friendly banter going on during this webinar.
It's not friendly, Cassie.
It is. I realized that came a little more sarcastic than I was intending it to. But seriously, guys, thank you so much for presenting. I know I had a great time. I hope the audience had a great time, and we'll see everyone next time.
Yeah.
All right.